I'm Pamela Fox, and today I'm talking about building modern Python web apps with Postgres. If you've ever thought about building a Python web app and you're trying to pick the technology stack, then this talk is for you. Let's get started. So, I am a Python cloud advocate at Microsoft, and that means that I spend a lot of my time these days helping Python developers use Microsoft technologies, one of them being Azure Postgres. But I just generally love to play around with technologies and learn new things and share what I've learned with everyone else. So I've actually been building web apps for quite a long time. I dug way back into the Internet Archive, the Wayback Machine, to find my original website from 1998. And it is a classic. I've got a web ring. I've got it optimized for tiny screens. It's called Pammy's Place. It's everything you ever wanted out of a 1998 website, right? Now, don't worry, I did get much classier a year later, as you can see, with my bright yellow website and the declaration. This is not a homepage, more of an online filing cabinet with lots of fun stuff on that website. So I've always loved building websites. It's one of the first things I discovered how to do on computers. And once I realized I could create websites, share them with the world, I've been hooked ever since. So I, of course, also have worked on professional websites. I was one of the first developers at Coursera in the first year that Coursera came out. Coursera is a online online website where you can take university courses. And it was really cool to get to work on that, to get to work with professors in order to deliver their vision. And then from there, I went to Khan Academy. And at Khan Academy, I actually was both a full stack web developer and I was the content developer for computer programming. So there, I was both programming the website and teaching people how to program. And that was super fun as well. And both of these did actually use Python as a backend. And that's where I, started really learning about how to build websites using Python. And as it turns out, these days in 2025, most developers are building web apps. This is a survey I found from JetBrains that they put out each year, and they ask, what are you building? And what we see is the majority of people are building websites. Some people are building a few other types of applications, but at least 42% of people are building websites. It's still a very popular form of software since it works on your laptop. It works on your phone. You could have it be a progressive web app that's, mobile friendly. Just web apps are so ubiquitous. So it's still a very relevant question of how do we build web apps? And this is a question that I actually get quite a bit. Like, okay, Pamela, I want to get into web app development. How do I get started? What technology stack do I pick? There are just so many options, right? So my goal today is to step you through my decision process for how I would build a web app, now in 2025. And hopefully that helps you with your decision process when you're developing web apps. So here we have a basic web app architecture, okay? There's a front end, there's a back end, and there's a database. Now, on the front end, that is going to be coded with HTML, CSS, and JavaScript because those are the languages that browsers understand. Of course, we can use a front end framework like React or Svelte or Vue or Angular in order to generate HTML, CSS, and JavaScript, but ultimately, that's what it'll be coded in. I'm not going to talk about front-end frameworks in this talk because we really want to go into the back end. And that's really a whole other talk that I've given in the past of how to pick a front-end framework. And it's a hard choice as well. But let's just assume that we're going to use HTML, CSS, and JavaScript in some form. So then on the back end, I am going to use Python. There are many other languages you can use on the back end. You can really use any language on the back end. Some are more popular than others. But since this talk is about building Python apps, we're going to use Python. And then, of course, for the database, we're going to use Postgres. This is a Postgres conference. We all love Postgres. It's a fantastic open source relational database, and it's a really popular and great pick for a database. So we're going to start with this architecture here. But we still have more decisions to make. So we see these, arrows back and forth that shows, we're communicating back and forth between these different components. So how are they going to communicate? Now, the backend with the database is going to be sending SQL queries and getting back, SQL results from the database. We know that much. For the front end communicating to the back end, there's actually different ways that you can have front ends communicate with back ends. You can have, back ends render templates. You can have them communicate over APIs. We're going to go with APIs for this architecture. So that means the front end's going to send a request like, hey, give me all the items from the items API. And then the back end is going to return JSON that says, okay, here's all the items. And then the front end will render that data. So we're going to go with what I'm going to call an API-centric backend. So that's how they're going to communicate. We've made that decision, but we still have more decisions to make. Specifically, we need to decide, are we going to use a web framework for that Python backend, and which web framework are we going to pick? Are we going to use an ORM in order to communicate with the database? And what Postgres driver are we going to use to communicate with the database? So those are the three big decisions that we're going to focus on in today's talk. Let's start with the framework. That's the one that most people start off with as a decision, and it will affect our other options. There are three really popular frameworks that if you're in the Python ecosystem, you've probably heard of. So the three most popular are Flask, which is a fairly lightweight and flexible framework. FastAPI, which is also fairly lightweight, but a little more opinionated, and it's very focused on API first development. And then there's Django, which is a very opinionated framework. It's the batteries included framework. So it actually comes with an ORM, it comes with an admin, it comes with lots of things. So very opinionated, but can be really great if you need all of that stuff. And as you can see this is from the 2023 survey, they're all quite popular. Django and Flask have been around for longer than FastAPI, so generally more people are using them. But I think if I check 2024, I'm sure the FastAPI stats would be even higher now. It's really growing quite a bit in popularity. So those are the top three that you'll hear about the most. But there are other frameworks in that are definitely worth considering. So the two I want to talk about today is Court, which is an async version of Flask. So it is actually even based on Flask. So if you bring in Court, you'll get Flask as a dependency. And then there's Starlet, which is the async framework that underlies the FastAPI framework. So if you are already using FastAPI, you're actually using Starlet because FastAPI is dependent on Starlet. So these are two frameworks that we could be using instead of these other three frameworks. So now we have even more decisions to make because there's 5 possible frameworks that we could be picking from. And what you'll notice is that for a lot of them, I mentioned this word async. What is async and why does it matter so much? Let's dive into that because it ends up being actually very important and is going to affect all of our decisions. So async is it's something that we can use in many languages. Here we're going to see how we can use it in Python. And basically, if we're in Python, we're writing a function. What we do is we put the word async in front of a function in order to mark it as an async function. And in this case, we would actually call it a coroutine. Once it's called async, we call it a coroutine. So this is now a coroutine. And if we are calling a coroutine, we need to put the await keyword in front of it, right? So you see here, it says await. That means that this function here is actually a coroutine. So we're saying, all right, wait for the results of this coroutine. And now in order to run this function, we can't just run it the normal way. We have to use this asyncIO package, which is part of the Python standard library now, and say, hey, run this asynchronous function. So it's a lot of, things we have to add in order to turn our functions into coroutines, in order to work with coroutines, but we do get a big benefit from it. So let's look at that benefit. And here I'm actually just going to open this demo. So here you can see I've got asyncIO, and I'm also using HTTPX for making a call to a web URL. And I've got this coroutine here, which I've marked as async. And what it does is it just fetches this URL and gets that, does an HTTP GET, and gets a response. That's all it does. And then in main, what I'm doing is I'm using this asyncIO task group functionality in order to basically send off 2 requests to to these coroutines and, send them off and then wait for the responses to come back. So let me go ahead and run this so you can see what happens when we run it. So you notice that it says, okay, fetching this URL /3 and then fetching this URL, which is /1. But then with the received, and this is coming from here, it actually received that second URL before it received the first one because that one was slower. And this is what we can see with async. If I had done this without async, it would have gone off, gotten that, and then come back, and then it would have been really linear, right? But when we're using coroutines, we now have the ability to send stuff off concurrently. So this is we're getting concurrency. So we're sending off these 2 requests, and we're doing it with concurrency so that if this one returns faster or returns earlier, we can actually get that return value first. And that can be really powerful. It can mean that we can write code that's more efficient, that can do things in a shorter amount of time because because it's able to actually send off these requests, both send off both requests and then they can come back at different times. Let's look at that another way. So here we have the function fetch URL. We go and we fetch the slower URL, right? So what happens is that Python goes off and starts making that network request and then pauses. And while it's pausing, it can go to this other and send off this other request for fetching a URL, which is a shorter request. And that can happen while we're waiting for this request to come back. This whole flow can happen as well. And then finally, the slower requests come back. So this is what's really powerful about concurrency is that if the Python code is blocked because it's waiting for a network request like it is here, it's able to work on another coroutine that is waiting and then be able to get more work done while it's waiting, right? So before we would just be completely blocked. We'd have to wait for that network request to come back. We'd be, unable to do anything else. But here with async, with concurrency, while we're waiting for that network request, we can go and send off another one and get more work done, right? We're able to get more work done. Okay. Hopefully that makes some sense. And basically, once we're using async, we can get a lot of benefit from it in some situations, right? So if we're doing IO operations, so if we're opening files locally, if we're reading the files, writing the files, if we're doing database calls, like a local Postgres database, all of those are operations where normally Python would have to wait for the response from the system, and it would just be sitting there waiting. And then the other thing that we just saw was network requests, right? If we're making a network request, and especially if that network request is slow, which happens with slow APIs, like modern API requests to large language models can be very slow. You can be waiting for seconds for them to come back, right? If you use async while you make that request to the slow hosted LLM, then you can do other stuff while you're waiting for that network request, right? So async is very helpful in those 2 situations. Now, async is not helpful if our code is doing CPU heavy operations or GPU heavy operations like math. So if we were like running our own LLM locally and having to do all the math there, well then that's actually the Python, that's actually Python code, like, it's actually like working there, right? It's doing work, it's not waiting. So then we wouldn't get the benefit from async. But there's definitely a lot of situations where we do get benefit from async, and that's why it's so compelling. So now that we talk about async, let's talk about how we use async with web apps. So first, how do we traditionally write web apps? There's this thing called WSGI, which is the Web Server Gateway Interface, and it is a standard way for web apps to interact with servers. So that means, if you're using Flask or Django or some other framework, they can all interact in a similar way with a WSGI server that can work with your web server, right? So a common setup would have like Nginx, and Nginx could handle both static files, and then it could send all the dynamic routes off to your WSGI server. And then your WSGI server, the most popular one is gUnicorn. So gUnicorn can run your Flask app or run your Django app. It can run any WSGI compatible app because it knows how to do that. So it's going to forward all the requests to your web app in a common way. So that's how standard web apps work before async. Now, with async apps, we have ASGI, the asynchronous gateway interface, and this can handle both sync and async routes. So, here, once again, we have a web server like Nginx, but it's going to forward the dynamic routes to an ASCII server like Uvicorn, which is the most popular one. So it's the only one I put here. And then that will forward the requests to the ASCII web app following this ASCII standard, right? So maybe that's FastAPI or Quart or Starlet. So what that means is that if we are using async in our web app, then we get the ability to handle many more concurrent requests, right? So this is very similar to diagram what we had before. So let's say we get in a request for API/generate answer, and then that goes off and makes a call to a slow LLM. While it's making that, it can handle another user request. So here it's actually handling 2 user requests and doing that concurrently. And so it's able to handle more than it could have if it was just a WSGI web app. It would have to handle it linearly. So that's what's really powerful about ASGI web app frameworks. Now that we understand async, we can look again at our framework options, and now it becomes easier to pick, right? We want to use async for modern web apps because we're probably going to be making database calls. We're probably going to be making slow network calls. We want to have the ability to have concurrency. So that means we're not going to use Flask. However, we could use Quart because that's the async version of Flask. So that would get us the concurrency. We could use FastAPI because that supports async. We could use Starlet, which of course supports async because it's the underlying framework of FastAPI. Django's an interesting one. It actually has partial support for async. So it would work to make async LLM calls, but it's not fully supported in the ORM calls. So we wouldn't get the async benefit from our database calls. So that's kind of a question mark there. Which one should you pick? This is a really hard thing to say. It's hard to compare all these, but I do have a blog post where I attempted to compare them. But generally one way of thinking about the frameworks is in terms of how opinionated they are and whether you want to work with that opinionated nature or if you think you'd be struggling against it. So generally I would say FastAPI is the most opinionated because it is designed for APIs and it has that in mind. It also has a pretty big ecosystem. You're going to find lots of tutorials about how to do FastAPI because it's so popular. Starlet, I would say, is the least opinionated, fairly flexible, has support for WebSockets, could be a good pick for some sort of WebSocket app. Quart's kind of in the middle. If you are coming from Flask, easiest to port to Quart because you just stick async in front of things and pretty much works. And it does have an ecosystem of plugins similar to the Flask extensions. So that's one way of thinking about which frameworks to pick. I've got a few more ideas in my post there. In general, I would say they're all great picks. I think they're all good picks for different situations, and I've used all 3. So I've used Starlet for an app that uses WebSockets. It was a good pick there. I've used Quart for quite a few apps that have both front ends and back ends with templates. And then I've used FastAPI for similar apps, especially ones where I really wanted them to be very API centric. Today, I'm going to be demoing FastAPI because that's the one that I used for the demonstration. But once again, they're all good picks. Okay, so we've picked our framework. It's going to be FastAPI. Now we still need to pick a Postgres driver and ORM. So let's start with the driver. We can look at, what are our options here. So these are the 3 most popular Postgres drivers. The traditional one is psycopg 2. However, that doesn't support async. So that's off the table because we really want that async functionality. There is a successor to that is called psycopg 3, but has a package name of psycopg, which is confusing. But it is actually the sequel to psycopg 2, and it does support async. And that's fairly popular because if you're coming from psycopg 2, then it's going to be fairly straightforward to go from psycopg 2 to psycopg 3. And then another option is asyncpg, which came about because of psycopg 2 not having support for async at the time. And if you look at the download stats, you can see that all the drivers are relatively the same amount of popularity, right? Most people are still using psycopg too. Most people haven't moved to using async yet. But the two async options are pretty much equal in popularity. So how do we reason about it? One thing would be performance. There's various blog posts and stats that compare performance. A lot of them do see better performance out of asyncpg, and that could be a reason to pick it. However, you do want to verify that you see those performance gains for your own uses of the drivers too. So, for example, someone was telling me that asyncpg, some of the performance gains are not compatible with PG Bouncer. So, if you are using PG Bouncer, maybe that will sway you toward using one or the other because you won't have as great performance gains. In this case, I did go with asyncpg, but once again, psycopg 3 could also be a great fit. So now we've got the driver. Finally, the ORM. Now, the question is, do we even need an ORM? And generally, I do like to use an ORM. I like the abstraction most of the time where I can use a Python object instead of raw SQL. It's nice to have IntelliSense and have type annotations and all that. That's quite nice. I like the portability where that in theory, I could switch between different database backends more easily. I like the security for sure, right? I'd never want to accidentally have SQL injection, and generally ORMs make it, much more secure, much harder to do accidental SQL injection attacks. And then I also like migrations, making it easy to add a new column, run a migration, and have that reflect in my database. Now, I don't always use an ORM because sometimes it can be hard to use that level of abstraction, right? Because as soon as you start using an ORM, you have to translate that SQL query that you know how to do into something that works with that ORM. And sometimes that actually can be really tricky. That being said, I still like starting with an ORM and giving it a go. SQLAlchemy is by far the most popular ORM, dwarfing all the other ones. You might consider SQLModel if you are working with FastAPI because it was made by the creator of FastAPI. However, last I checked, it doesn't support async, so I won't be using it in this case. So we're going with SQLAlchemy, which does have first-class support for Postgres and support for async. Now we've got our whole web app architecture put together. We're doing Python with FastAPI, with asyncpg, with SQLAlchemy. Let's check out and see what this looks like in an application. I'm going to be showing you this demo, which does RAG with a Postgres database. It works both locally with a local Postgres, with a Llama if you want to use that. And it also works in deployment with Azure, OpenAI, Azure Postgres Flexible Server, and container apps. And you can get the code for it from the repo linked on the slide. So let's go ahead and check that out. All right, so here I've got it running locally. So I'll go ahead and show you just what the full running application looks like. So I'm basically, I'm a user that's asking questions about products in a database. And this is basically I'm asking questions of an outdoor shop. So pretend this is REI or your favorite outdoor products website. And, we get back a response that says oh, we've got 2 climbing gear options under 30. You can check out this one or this one. And here's all the information. And here's some references, right? So this is what's known as RAG, Retrieval Augmented Generation, which is a popular approach to using LLMs in order to answer questions about our databases. Okay, so this is working. So how does this actually work behind the scenes? Let's take a look at the relevant code. So first, when we set up the Postgres engine, we have to use asyncpg. So that means we are going to use this special database URI, which says that we're using the asyncpg driver. That's how we make sure that we're using the asyncpg driver with SQLAlchemy. And then with SQLAlchemy, we are using the create async engine, which ensures that everything's going to be doing async. So that's our driver and ORM setup. And then we can declare the models using SQLAlchemy classes, right? So here I'm using SQLAlchemy 2.0, and I'm describing this item table and saying okay, here's my ID. It's got a brand, it's got a name, it's got a description, it's got a price. It also has embedding columns. These are using PG vector so that I can have vector embeddings for each of these items so that I can then do vector search. And I've got ones for different models so that I can switch them out local versus prod. So that's how we can use the ORM in order to describe our Postgres table. So now I can go and check out the FastAPI docs. So these are the auto-generated docs that FastAPI will make for you out of all your routes. And this is one of the things that people love about FastAPI is that it produces your opening.api.json, and then we can make these docs based off that opening API, and it's just made for us, right? So here we can try out an ID and see, okay, this is, that row from the database. Great, that worked. And if we look at the routes, this is what the route looks like. We say, okay, we're getting that ID. Then we're sending off a query using SQLAlchemy. And this is the ORM query language here where it says, okay, we're going to select the item where the ID equals this, get that, and return it back. Now, going a little fancier, we can do a similarity search using those vector embeddings. So we say like, okay, give me everything that's the most similar to that product, right? And remember that was a boots product. And so we got back a bunch of boots, shoes. Okay, so those all look pretty similar. That was using vector similarity. So if we look at the code for that, what we see here is that I start off with getting the target item. And then here, what's interesting is that I decided to just straight up use asyncpg with a SQL query, because in this case, I found it easier to write the SQL query than to use the ORM. So this is one of these examples where I like to start with the ORM, but sometimes I will, go lower level and do a straight up SQL query because it's shorter, it's easier than trying to translate it into the ORM language, depending on what I'm trying to do. So you still have the option to go into SQL if you need it at times. Okay, so that worked. And then we can do a search. So here I can actually type in a query. So I want climbing shoes, and I'm doing both vector and text search. Okay, and then we get climbing shoes, we get running shoes, we get a climbing harness. It's not quite a shoe, but it's related to climbing. And that one is a little more effort. And here I've got a whole class for it. And so once again, in this case, I am using SQL because I'm doing a very complex hybrid search, which is combining vector search and full text search and then coalescing them together and, getting those final results. So I execute that and then, turn that back into SQLAlchemy models. So this is another interesting mix where we're doing both SQL and using the SQLAlchemy where it makes sense. All right, so those are the basic API calls, and then there's a final API call, which is the one that's used by the actual front end in order to answer these questions. And so that does the search and then sends it off to an LLM and answers the question. But there you go. That's basically how it all works. We've got the routes, we've got the driver, we've got the ORM, and we can use them all together in order to create this application. So you can check out code if you want to dive more. So now some final thoughts. Hopefully now you know a lot more about your options and have some ways of thinking about them and realize the importance of async, because a lot of people aren't thinking about that right now. I just want to really make sure people are thinking about async and the benefits of it. But there's, of course, many other things to consider besides that, right? You always want to think about security, how well maintained some things are, how nice the community is. The Postgres community is super nice, right? How accommodating they are, how great the tutorials are, how extensible they are. So many different decisions go into picking your technology stack. And it's important to, know what's important to you, know what all the options are so that then you can decide. And if you do decide, pick something and you have an experience with it, I do encourage you to write up your learnings and share them with the community so that we can all learn together. Like, oh, this worked really well for this. This didn't work as well for that. And that'll help all of us to make a decision. Sharing is caring. And that's my talk today. Thank you.